ladies and gentlemen. Thank you for joining us today for this important discussion on non-conventional water resources for arid regions. We have already heard a lot of great presentations and discussions this morning on the importance of non-conventional resources on which we rely not only in Qatar but across the GCC and increasingly in other areas of the world as well. So I'm the moderator for this session. My name is Dr. Jenny Lawler. I'm Senior Research Director for the Water Centre at Qatar Environment and Energy Research Institute. And I'm honoured to introduce you to our distinguished panel of guests. And these are experts from both industry and academia. So we have the promise of a very exciting and informative discussion this afternoon. So I'll start with Dr. Yousef Wehbe, is the Chief Science Officer at Weather Modification International, North Dakota in the USA, and he is also a member of the Strategic Directions Committee for the UAE Research Programme for Rain Enhancement Science. This is an international merit review research programme under the UAE National Centre of Meteorology, designed to stimulate and promote scientific advancement and the development of new technology in this emerging research field. So Dr. Yousef's areas of expertise include water resource management, coupled land atmosphere modelling, cloud microphysics, and weather modification technology. And his ongoing research addresses next generation water resource monitoring by integrating satellite and radar remote sensing, hydrometeorological modelling, and relevant applications of AI and machine learning tools. So welcome, Dr. Wehbe. Thank you very much for joining us today. To the next speaker, Mr. Mokrane Khaldi is the business manager at SLB Schlumberger, which is a global technology company driving innovation for a balanced planet. Mr. Mokrane is managing the water services business line, and his extensive experience includes working on strategic groundwater and sustainability projects across Qatar and the Middle East, collaborating with diverse organizations here such as Ashghal, Qatar, Ministry of Environment and Climate Change, and Qatar Energy. Currently, his primary focus centers on advocating for digital solutions as catalysts for enhancing water efficiency. He's dedicated to the sustainable utilization of produced water from the oil and gas operations, contributing to both environmental and operational sustainability. In addition, Mr. Khaldi is at the forefront of the energy transition landscape, where solutions are intricately tied to water management and emissions reductions. Thank you very much for joining us, Mr. Mokrane. Our next panelist is Dr. Stephane Prigent, and he has been serving as the head of the Wetland Competence Centre at Bauer Resources since 2015. As the department head, he specialises in eco-technologies for the sustainable management of contaminated waters, and he's taking responsibility for wastewater treatment plant design and engineering, technical business development, cost estimation, project risk assessment, and quality control on projects implementation. Stephane's international experience is demonstrated through his involvement in various noteworthy projects, including the Nimr water treatment plant in Oman and the Reed Box patented technology in Oman, Jordan, UAE, Saudi, and now in Qatar. Throughout his career, he has successfully dealt with sewage, produced water, industrial wastewater, and stormwater in different countries located in the Middle East region, as well as in Europe, North America, Africa, and Asia. In addition to his role as the head of the Wetland Competence Centre, Stephane has contributed as a research project coordinator on the optimization of existing constructed wetland technologies, as well as the reuse of treated water and biomass from constructed wetlands. Thank you very much for joining us, Dr. Prigent. Our next panelist is Dr. Sudhir Sharma. Dr. Sudhir is the CEO and co-founder of Greenboom, a company that manufactures sorbents for oil spill cleanup and remediation to make this a waste-free process. Dr. Sudhir is currently working on the US Department of Defense DARPA project for atmospheric water extraction in extreme climates as the chief scientist. Dr. Sudhir holds a BE in Chemical and Materials Engineering from the University of Auckland, an MS and PhD in Chemical and Biomolecular Engineering from Georgia Tech. Thank you very much for joining us, Dr. Sudhir. And last but not least, our next panelist is Professor Esra Aleisa. Esra is Associate Professor at the Industrial and Management Systems Engineering Department of Kuwait University. Professor Esra's research interests include system simulation and life science assessment, mathematical modelling and statistical analysis for sustainable development, cleaner production, municipal solid waste management, and wastewater treatment. She has accomplished projects in collaboration with the United Nations Commission Committee, UNCC, in regard to post-war environmental remediation, particularly relevant today, the United Nations Environment Programme, UNEP, the United Nations Industrial Development Organization, and Kuwait Foundation for Advancement of Science, KFAS, on national resource efficiency and cleaner production. Thank you very much for joining us, Professor Esra. So, each panelist will now have just a few minutes to tell us briefly about their company or research area and its relevance to non-conventional water resources. So, let's start with Dr. Sudhir. So, Dr. Sudhir, please tell us about your work and Greenboom's mandate. What are the key challenges and opportunities that you see in addressing water security in arid regions through non-conventional water resources?
Sure. So Greenboom's primary work is in the area of sorbents and oil spill response. It's very important in this region because a lot of water is produced from desalination, and desalination intakes have a high risk of contamination by the oil and gas activity. So that's our primary work. The other project that Dr. Jenny mentioned we're working on is production of water from atmospheric humidity in extreme climates. So one of the resources that is underutilized is the humidity. Now the problem with extracting humidity or water from humidity is extremely energy intensive. The easiest way to do it is by condensing the water, and that's a known technology that's available, but the cost of water produced is too high for consumption. It's much higher in cost than desalinated water even. So we're working on technology that can passively collect water from humidity by the use of highly efficient sorbents, which can collect the water passively, and then they can release them upon application of a very small amount of heat or vacuum. And that's one resource that we see is very underutilized at this time because of the lack of technology.
Thank you very much, Dr. Sudhir. It's really fascinating, and definitely the humidity capture is really, really relevant in this region. Mr. Mokrane, can I go to you next, please? Can you provide us with an overview of SLB's involvement in this field? So what kind of innovative solutions is your company working on to address water scarcity in arid regions?
Yeah, Dr. Jenny, thanks for having me. So as SLB, we're a oil service company, right? You know, we work a lot in the oil and gas, but water is there, right? So we do help the society or the communities in two ways. We help the authorities, the agencies, and as well we help the oil and gas in this field. So I do remember when I started here, you know, you came to Qatar and they said, what project you were working on? It was not the scarcity, it was more water. At that time it was much excess of TSC, what to do with it, right? This is where we brought our oil and gas expertise, you know, to subsurface to find the best way to use this water. There is an excess, you know, at that time the country was booming, the population was growing, but the infrastructure was not following, right? You know, you have to dispose this water. Ideally, use it for irrigation, right? But there are no enough farms. There are no enough landscaping to use this water. So this is where it came. We helped the authorities here to find out the best area where to store this water. At that time, it was disposal to store it. Now we're talking about recovering this water. So it was a challenge. Now it became an opportunity. The same thing we're doing with desalination, right? You consume more water in winter. However, you consume less water you consume more water in summer and less water in winter. What to do with it, right? You leave it for evaporation is a loss. Can we store it? And this is not only just storing it for using it, it's a strategic, right? You know, Qatar now is moving, they were moving from 2 days to 7 days with the mega reservoir. They are moving to 90 days sufficiency in water when this ASR are implemented. It's not only Qatar, it's the region itself. You know, ASRs will be implemented everywhere. This is from the agencies and the authorities' perspective. When we come to the oil and gas, you know, I'm not sure if you have heard about water cut. you produce 1 barrel of oil, it comes with it 4 to 5 barrels of water. So we used to say, maybe the oil and gas people will not like it, it's water industry and the oil is byproduct. It's not, we are producing more water, what to do with it? Definitely there are ways, they need it in the operations, but there is excess. Instead to dispose it, contaminate the aquifer, instead to put it in evaporation lagoons, we have to find a way, and this is what we are working on, to treat this water and reuse it for irrigation and different stakeholders, right? And the last one is digital, benefiting from the data we have, use digital as enabler, so to fast track the path to the results. We used to spend time looking at the data, but can we get the information quickly? We are discussing about the emergency, about the security. Can we do that? I think that's what we are adding into the area of water from Schlumberger.
That's fantastic. Thank you so much. And it really kind of covers this spread between industry and municipal that we have here in Qatar. Dr. Stephane, can I go to you next, please? Can you please introduce to us Nimr Bauer and share your insights from the industry's perspective? Can you discuss the role of technology and innovation in harnessing these types of non-conventional water resources for water security, please?
Thank you for the introduction. Bauer Nimr is a daughter company of Bauer Resources. Bauer Resources is being a segment of the Bauer Group. You might know Bauer in the Middle East region, especially in Qatar, in the UAE, as the Bauer Foundation for the development of special foundation for skyscrapers. Bauer Nimr is a company really specialized in the wastewater service as well as waste management. This being said, we have been talking over the day about desalination to supply potable water, either for the individuals, but also for the industry. Here in the Middle East, the major industry is oil and gas, demanding a lot of water. And this will continue to increase over the next decade. In terms of innovation, I wanted to bring the Nimr water treatment plant project, which is here not taking water from the desalination, but from the ground. So the Nimr water treatment plant project is treating about 175,000 cubic meter per day of production water. This being in the middle of the country, approximately in the middle of the country. It covers a total area of 2,000 hectares. It's based on the constructed wetland technology. So basically the wastewater contaminated with hydrocarbon is being treated using microorganisms attached to the wetland plants. This is occurring in earthwork basins, and the water is being then free of hydrocarbon. To date, this treated water is being discharged in evaporation ponds, but as part of our commitment to find alternative solutions for the reuse of the treated water, we implemented years ago, approximately 5 years ago, a research and development project to irrigate endemic tree species, approximately 15 endemic tree species, as well as imported trees such as jojoba, over 20 hectares area, and we did use different methods of irrigation. So this is an alternative opportunity here, where we can reuse the treated water from the industry. Additionally, what is to be mentioned is that this treated water is being brackish, about 6,000 to 7,000 ppm TDS. So we are dealing here with a biosaline agriculture project. So it's an out-of-the-box project that comes out of the irrigation standards that has been allowed in the country of Oman. And we can see successful growth of different trees, specifically jojoba, that is also bringing business opportunities in the country, where these jojoba seeds can actually be used for the cosmetic industry at a later stage. So these seeds contain 50% of oil that is being directly used in the cosmetic product.
Okay, that's amazing. And we've heard a lot as well about the potential for these type of biosaline agriculture for energy crops, for various different uses. So it's a really different and interesting area for research. It's fantastic. Let me move on to Dr. Wehbe, please. Could you introduce to us WMI and highlight your research focus in the industry? Because this is quite different to what we've heard from the previous panelists, a totally different perspective. So can you tell us a little bit about your research focus and how, there's elements of public-private partnership that are necessary here, and how can this play a role in promoting sustainable water solutions, please?
Thank you, Jenny. As you correctly note, most of the panelists, my fellow panelists, interventions are more on the ground-based part of things. WMI, Weather Modification International's area of intervention is obviously in atmosphere, like the name states, with over 50 years of experience in both operational and research services across the wide spectrum of climate, meteorology, and more atmospheric sciences. We've delivered both, as the name states, we're focused on weather modification in the form of both cloud seeding programs, as well as hail suppression. So they both dual extremes of the spectrum, essentially. We have clients all over the world, across the United States, more recently in Europe, as well as a very important historical background here in the Middle East. We've partnered with the Kingdom of Saudi Arabia in the past, UAE, Oman, and more recently with Saudi Arabia again, with the Ministry of Environment and Water. We have an operational cloud seeding program there, launched in 2019. As well as an in-tandem research program going on. In addition to that, I'm very fortunate to be part of the steering committee at the UAE Rainfall Enhancement Program, and that gives me direct access to some of the brightest minds on the research side of weather modification. Members of the WMO expert team on weather modification, which is a UN organization that basically publishes regular reports on this emerging field of research. So I'm very fortunate to be on both sides of the spectrum in terms of operational technology, but also on the R&D sides of things. On the second part of your question for PPPs, essentially, I think it's a proven framework for success in any infrastructure project, so having both the public and private sector working closely together, but particularly when you're looking at developing new technology in a field like unconventional water resources. So that's really the key of having sort of the government entities giving the framework or boundaries of both governance, regulatory framework, and the right amount of funding to get that, to tap into that innovation from the private sector. And that really gets you into sort of the Goldilocks zone, I kind of name it, and where essentially you're getting the scalable technology that can go to the market, rather than staying at the blue sky science with the great research being done at the university level, but having that support and sort of boundaries set from the government regulatory framework really helps you get into the higher TRL spectrum of getting to the commercial realm of things.
Mm-hmm. It's really interesting, and particularly in the context of, you mentioned hail suppression, which is not something that I realized was part of your remit, because we had a storm here a couple of weeks ago, and there was huge hailstones. You know, people's cars were getting damaged, but it wasn't that cold. So I need you to tell me more about how this works. Because I'm from Ireland. We get hail when it's, you know, 2-3 degrees.
So one of our biggest customers is Canada.
Okay.
As we all know, Canada is one of the biggest countries with the hail problem, and particularly the insurance companies. So a lot of funding comes from the insurance companies to fund hail suppression programs in Canada, Alberta specifically. We've had an operational program there for over 10 years. So it's been a very, I would say, a nice example of sort of hail suppression, but also rainfall enhancement. So you're on both sides of the spectrum.
Okay, fascinating. Let me go finally to Professor Esra. So to come almost a full circle from the very industry-orientated side through the public-private partnerships to your area. So can you give us, please, some of the key findings from your research that can contribute to water security in arid regions? And being from Kuwait, can you give us a little bit of insight into how can the GCC and other countries collaborate to solve the issue of sustainable water in the future? Because this is somewhere that you've had a key role in the past. Thank you very much, President.
Yeah, well, thank you. I'm glad to be here. So I come here with two hats. The first hat is a professor at Kuwait University. We study the entire water network. Coming from an industrial engineering background, we optimize the supply and demand. We look at the entire network from the sea to desalination to municipals, waste treatment and the reuses, especially that we were the first in the GCC to have the desalination plant in 1951. And we have the biggest wastewater treatment plant worldwide. On the other hand, we're the first when it comes to water scarcity worldwide. So we have both extremes. My other hat that I come with today is I do represent the peer-to-peer transboundary water corporation / conflict network. This is a project funded by the National Science Foundation and USAID. We study the catastrophe of the Aral Sea in the Central Asia and the lessons learned, like the aftermath, like the Aral Sea. You know, it's like almost 16 times the size of Qatar, and it's almost dried now. And one of the things that we have learned, beside the change in the trade, the distribution of people around it, the agriculture that have disappeared, is that some of the accumulated salts after the sea had dried is now going to the glaciers, and it's accelerating the melting of the icebergs and to an unprecedented speed. So we do study these things. We study the Urmia lake in Iran, the one that also have almost dried out, and we try to project and reflect that to what could happen to the Arabian Persian Gulf. And what could happen if we cooperate or fail to cooperate when it comes to the transboundary shared or transboundary water. So,
yeah.
And your question was regarding the lessons learned. So we kind of try to project that, and we also do measure the carbon footprint and water footprint, including the virtual water, the production of water costs.
Yeah, that's a really,
to derive
really
future
important
policy.
Yeah. So how can we move forward, and particularly how the different lessons can be transferred is really important. Okay, so thank you all very much for the very insightful introductions. It's great to know a little bit more about your background and what you do. So we'll move on to the main segment of our panel discussion. So let me go again to you, Dr. Sudhir, please. So as a company who's recently established here, can you tell us how, you've come from a non-arid environment into an arid environment. So can you tell us how your company plans to contribute to the sustainability of non-conventional resources? You're based here now in Qatar, but presumably that can also look at other arid regions with similar challenges.
No, that's absolutely correct. So the main reason why we're working on producing water from humidity is because it's a non-point source. So you have desalination systems that are large and can produce large amounts of water for industry in tar cities, but in case there is failures or operational failures in those systems, there's suddenly a lot of cascading effects. So that's especially the case here in arid regions, right? So when you have non-point source water production where you can produce water wherever people are, so either for home use or for agricultural use from the air at low cost, that can reduce the risk of such events and also reduce the risk of, or reduce the load on desalination systems. And that also then has cascading effects into brine production, for instance, because if you reduce the load on desalination, you can also reduce the load of salt being, the brine being sent back into the ocean, which causes effects that we're just starting to measure. So increased salinity in the Persian Gulf and other regions of the world as well. So those are really the main things we're trying to resolve. And of course, with all of it, there's also the issue of cost, because with desalination, you also have to build out entire distribution systems, which then have to be managed. With more points of production, you can also reduce the risk of failure in those distribution systems, especially here in more arid regions.
We've seen the great interest in production of water from humidity in this region. Very much exemplified by last year, the year before, there was a call from our national funding agency, the QEERI Council, in conjunction with one of our largest food producers, Hassad Foods, looking at exploring the potential of capture of water from air for agricultural purposes on a large scale. Yes. There are concerns, I would say, that this is essentially a weather modification effort. By the time you look at large-scale production or capture of humidity from air, you're looking at large-scale movement of air to accomplish that. And there are concerns around that. So by the time, I mean, essentially that humidity is coming from the sea, right? So it's the same source as our desalination. What would you say to those kind of concerns? Is this weather modification? Is it sustainable? Can we do it on a large scale, or should we just focus on the small scale systems?
Sure. So this is fairly new. The technology for producing water from humidity has existed for a while. Basically, you can condense the water out. And there's some commercial solutions for that also. But you're right, they've always existed for very small scale water production. Even the research we're doing right now is for small scale. So it's for use at home. There's some agricultural interest now as well. I've seen some preliminary studies that claim you need to produce giant amounts of water, large industrial quantities to have any effect on the weather. From a very rudimentary perspective, you would imagine if the amount of rainfall here is quite limited, and technologies like cloud seeding are trying to do essentially the same thing, to produce rain from that humidity. It's quite similar in that sense. Instead of producing rain, we're actually just capturing some of the humidity that already exists due to the evaporation that happens. But yeah, you're right. There needs to be more extensive research into what the effect of producing water from that humidity is as compared to desalination. Those effects are, I think, unclear.
Yeah, I mean, I would love it if you could, make it less humid here 6 months of the year. That'd be sort that out, please.
Yeah.
All right, Mr. Mokrane, I'm going to go to you next. At SLB, can you provide some real-world examples of successful projects that have effectively addressed water security challenges for the region, please?
Yeah. I will bring it to the discussion we started, right? Helping, this excess of water we need to store. I think we implemented the first successful ASR in the Emirate of Sharjah, and they're still using it.
Can I just interrupt you to expand the acronym ASR for those in the audience that don't know what it is?
It's what we say aquifer storage and recovery. It's basically stored water underground instead of storing it on the surface, right? If you look at it from the economic perspective, for the same value of water, you can spend only 20% for the ASR, for the aquifer storage and recovery, than the mega reservoir. And as well, through the discussion in other panels, there was a discussion about water weaponization. Those are water is stored underground and they are not reachable, right, compared to the desalination plants or to the mega reservoir. And in case if desalination plants are not working, you are storing the water for a certain time at least, right, in the time to sort out your challenges. So we have implemented this in the Emirates. We did the pilot here in Qatar. We studied the southern aquifer, and it's working fine. And now Kahrama is going to the full design, so they will go to the mega ASR, aquifer storage and recovery in the north of Qatar, where they will store up to 90 days of water capacity. That's from utilities. When it goes to oil and gas, what we are doing is within our operations, right? The oil and gas, they consume a huge amount of water. When you go to, let's put it in a nice word, exploiting the reservoirs with hydraulic techniques, you need a huge amount of water. Just to frack, let's use the word, one well, you may go from 100,000 to 100,000 barrels to do the operations, right? How you can reduce that? That's what we're working on, not just on the water itself. Developing a new chemistry, a new polymers, which will consume less water. That's from this operation. When it goes to drilling, the same thing as well. Can we use less water mud? Oil and gas is here. You have to produce, right? They're talking about the peak of, it will be 2030, 2035. An article was published 2-3 weeks back. They're talking about 2046. The world needs this industry, right? But what we can do, we have a trilemma here. We have what we call availability, affordability, and sustainability. Availability, we need oil, right? Whatever we are, I'm sitting here on hydrocarbons, right? We need oil. The energy transitions are as well, trying to catch up, but we don't have the full solutions. We need to try to see how we can provide this need, which is the oil, affordable, should be cheap as well, otherwise, the inflations, and we cannot do this. It will be impacting the worldwide populations, and sustainability. And this is where water comes, right? Sustainability is not only carbon. If we reduce the amount of water to be treated from the desalination plants to be used in the oil and gas, you will reduce your carbon footprint, right? That's number one. If you reduce as well water which will be taken from the aquifers, it's not here in the Middle East, it's not here in Qatar. All water is coming from desalination, but you go to United States, there's a fight between the farmers and the oil and gas industry, how we can reduce reliance on the groundwater. Now, a farmer is to invest in farming, he may sell water for oil and gas operation because it's more expensive, more beneficial for them, and you see the social impact out of it. So we're trying to see how we can run those operations efficiently and reduce the water consumption, right? And the big one, which is coming and everyone is talking about it, is the produced water. Bauer is doing all this wetlands to treat water, but how we can treat the produced water which has higher salinity. I know that research are happening. Qatar Foundation is doing this, QEERI is doing this. All companies are doing that, and I think this is where we are pushing as well to implement technologies. Technologies are there, but is the cost. Reduce the cost of these technologies. They can be accepted by clients or the end users to treat this water. If you look at it, producing now 80 million barrels of oil, it comes with a 250 million barrels of oil worldwide, of water worldwide. Can we treat this water for the benefit of the communities? That's something we're working on, and we hopefully will reach a breakthrough soon, and we can provide the solution.
Yeah, I agree. I think it's really critical, and not only for water sustainability, but also for general environmental sustainability. And exactly. I think there's a big research effort needed to reduce the footprint of these type of systems as well, so that they can be sited offshore as well as onshore. We can look at minimizing discharge, the marine environment. We have a very, very sensitive marine environment here. So I think it sounds like the work that Schlumberger is doing in that area is really critical.
I totally agree with you. We need to look at it from the integrated perspective. It's not just solving issues from here and here. We need to link everything together, right? Even the produced water, which is now maybe a waste, it has to be a resource. If it's treated by agriculture, it can be used by agriculture. And there are other as well areas where we can save costs. Can we extract minerals out of it? Critical minerals. Can use the geothermal energy out of it. Some of the produced water is hot. Those are things we need to link together and provide a good picture especially financially, that's the driver sometimes, for investors.
Yeah, for sure. Dr. Stephane, you've told us a little bit about constructed wetlands and how they work, and they're essentially a nature-based solution that could potentially supplement in providing a sustainable water source for arid regions. Do you think that they should be integrated with more technological solutions such as desalination? So you mentioned that you're seeing brackish water coming out of these. Also, Mr. Mokrane mentioned we're working with produced water here that is brackish in nature already. We're looking at 6,000 to 7,000 parts per million TDS, which is maybe more benign than what we might see in maybe older oil fields, for example, or maybe in other regions of the world. So can you tell us a little bit about that, like these kind of hybrid nature-based, technological-based solutions and how they can help in water security and sustainability?
Yeah, sure. I just want to put the constructed wetland in its original context, let's say. The Nima water treatment plant is a unique project, one of the largest constructed wetland in the world.
You can see it on Google Maps, right?
Exactly. We can see a dot on Google Maps without zooming at it. But originally, this constructed wetland has been developed in Europe for the treatment of sewage.
Yes.
Right? And I must say there are more than 10,000 references of constructed wetland to treat raw sewage. Even in France, that's the state-of-the-art technology for more than 5,000 villages, less than 2,000 people equivalent. But the constructed wetland should be seen and implemented here in the Middle East in a holistic approach, I must say, as we do generate biomass, which is a source of carbon, and we do integrate a sludge management, let's call it biosolids, as we can actually manage the solids from the raw wastewater over a period of 5 years that is very similar to a compost. So here we can tackle with the constructed wetlands on food security as well, where the quality of the soil here in the Middle East is quite poor for agriculture. So it definitely requires an input of organic matter. At a local level, or at a decentralized level, where farms exist, we can implement such technology, input the soil as well with the compost and carbon being produced from the wetland, together with a sustainable irrigation of the treated water from the wetland. If implemented in remote areas in the Middle East, there is also the avoidance of transportation of this sewage by truck, right? Here it's quite common to see trucks driving around the city where we can actually decentralize the implementation of sewage treatment plant to just reduce the carbon footprint of our wastewater management. In the second context, you were mentioning the combination of constructed wetland with desalination. My first example was on the reuse of the treated water from Nima. What I mentioned it was a brackish type of water, but this was being allowed in Oman. In Qatar, for example, on the project we are working on with the treatment of the produced water, where the salinity is around 5,000 ppm TDS. However, in this case, we are not allowed to irrigate at such salinity. So in this case, we'll need to implement a desalination. And the next exercise is to understand, okay, does this combination of two technologies make sense economically to be implemented at a larger scale? This will be the question we'll answer in Qatar in the coming months.
Okay, that's absolutely fascinating. Professor Esra, as we look at the potential for implementation of these type of technologies and hybrid solutions, can you tell us about the integration of approaches such as life cycle assessment into these kind of solutions?
Yes, thank you for this question. So in life cycle assessment, we look at water production from cradle to grave. And what we have discovered that location is really critical when it comes to water desalination. So, for example, we have investigated the carbon footprint and the water footprint for water production. Although reverse osmosis uses like 1/5 of the energy, or sometimes even less. But on the other hand, it uses, the water footprint is really expensive, but we don't feel it in Kuwait because it's virtual because of the amount of chemicals that are used. Beside that, there is another aspect, which is the risk. Kuwait is located at the northern part of the Gulf, so we have sediment coming from Shatt al-Arab. And now, with all the dams that are built in Turkey, look how far this is. But it's affecting the waters that are flowing to the Gulf. So the salinity is increasing, the turbidity is increasing. So our reverse osmosis plants are working to 30% of their capacity. And because of the rising temperatures as well, we're having seasonal blooms of algae. This is also shutting down these the reverse osmosis facilities twice a year. So we have 3 of them. We cannot operate to full capacity. So we have the MSF, which is it consumes a lot of energy. And we have the MED, which generates 30% of the water supply in the country. Every meter cube using MSF or MED requires 15% of the amount of water to generate. But when you generate the same amount of water using reverse osmosis, if it's for desalination, it uses exactly the same amount of water, which is huge. But if you're using reverse osmosis for wastewater treatment, it uses even double. So 2 meter cubes of water will produce 1 meter cube of water. But this water, we don't feel it in Kuwait because it's used in the production of chemicals. And we know, like in the future, the water scarcity problem is increasing. So we know that the production of these chemicals will be a problem even abroad. And the prices of these chemicals will be higher, and the scarcity of these chemicals will increase. So there is a potential, like we are relying on desalination as if it's something that will always be there, but it's highly dependent on chemicals, especially where I come from. And also we've been through war, the Gulf War. And we look at desalination like you have like unlimited supply of water, but when it comes to risk, it could go away and then you have to rely on the groundwater. So considering the carbon footprint alone is not enough. We have to consider the water footprint and the robustness and the security of the technology itself. So this is what we have learned from life cycle assessment. The water footprint of reverse osmosis for wastewater treatment is higher than desalination in MSF and MED. Yeah.
That is honestly something that I had never considered before, particularly for wastewater treatment, because we typically look at seawater or brackish water reverse osmosis here. So that's kind of mind-blowing that's something that could be really, really really difficult to deal with.
It's not justified to have wastewater wastewater treated by reverse osmosis in Kuwait. The initial plan was to use it to inject the aquifers because they're depleting and they're not getting replenished. But then the parliament, and then for religious reasons, they stopped the project, and the water was disposed to the sea for like 10 years, which is 10 times purer than potable quality drinking water. But sometimes these social things and perspectives.
Yeah.
Yeah.
It's a really interesting point, and the fact that your desalination plants are only able to operate
The RO.
not the RO
the
plants,
RO. Yeah.
just kind of brings me to comment on the robustness of these plants and how pre-treatments and protection from environmental issues are really important. And just to point out, that's something that Dr. Sudhir is working on in terms of protection of desalination plants from oil spills in the Gulf. And it's becoming increasingly important as we look at weather patterns, for example, and the deposition of sediment in the Gulf, that we see these algal blooms. We're not suffering terribly from them here in Qatar at present, but we know that with the changes in climate and weather that are coming down the line, it's something that we're going to have to be really very well aware of. Dr. Wehbe, let me come to you next, please. In your opinion, speaking about the potential impact of all of these modelling solutions and tools, but what kind of policies and regulations should government and industry consider to promote responsible resource management in arid areas? And let me just ask you maybe a controversial question, because this is something that is, discussed. We don't do cloud seeding in Qatar, to my knowledge. But you would sometimes hear complaints, they're seeding in UAE and it's really humid here now and it's raining here now because of what they're doing in UAE, or things like that. So can you tell us, is cloud seeding really controllable over small geographic areas, or could there potentially be unforeseen consequences?
Thanks, Jenny. I'd like to first zoom out and say kudos to you and the conference host. It worked out very nicely because if you think of it as a conceptual model, we're tackling essentially the full space of the Earth and atmosphere. So you have the subsurface expert here next to me, you have the surface expert with the wetlands, you have Dr. Sudhir on the atmospheric water generators, and of course Professor Esra in terms of the life cycle assessment of comparing these different areas of intervention and bringing it together. So you touched on an important distinction first in the comment to Dr. Sudhir on, is it considered a weather modification tool to say atmospheric water generation? I think the key area is that atmospheric water generation is essentially operating in the boundary layer at relative humidities at the surface of up to 60%. Aside from when you have fog, obviously. Whereas weather modification in general is direct intervention at the source. So you're tapping into really the microphysical processes in your cloud systems. So just think of it as sort of a source intervention and then sort of a secondary intervention at the boundary layer. And right off the bat, in terms of there's the sustainability concerns that you mentioned and what we can do to sort of highlight the differences there. Right off the bat, I can say is that the weather modification technology in general, relatively speaking to desalination, requires no significant energy-intensive processes. And that's just setting aside the emissions associated with operating aircraft, et cetera. So there's no energy-intensive processes in the intervention in the atmosphere.
Can I interrupt you?
Sure.
What about the production of the seeding materials?
Great question. So that was my follow-on comment. The other concern was on seeding materials, both on production cost and atmospheric implications, toxicology implications, and then sustainability as well. So the materials are naturally occurring, particularly the ones that are used in the region here. So hygroscopic material, and that's essentially natural salts. So your table salt, which is sodium chloride, readily available from your brackish byproducts from the desalination plants. So cost is not an issue, environmental impacts are not an issue at this stage. Even when you talk about silver iodide, for example, which there's been some concerns about that in the US when cloud seeding started there. There's been pilot projects with the EPA, with other government organizations, consulting firms, third-party sort of ground-based validation and sampling in snowpack and rivers and across the biota. There's been no significant statistical evidence that there's any bioaccumulation of silver iodide from seeding. In fact, the background existing silver iodide in nature is in the order of parts per billion. If you were to model it in a fate and transport model, you would only get to a trace level of parts per trillion, when you're looking at any secondary effects from seeding. So that's sort of just to sum up the misconceptions of both areas of intervention and also the concerns of the types of material, where it's coming from both a techno-economic point of view. But yeah, I can expand as well on the cost side of things, but for me personally, the environmental concerns are key first. But we can talk about costs maybe later if time permits. Yeah.
But the other part of my question was, if you seed in UAE, is it going to rain here? Can you control this?
Yeah, so the analogy I like to give on that is, are we robbing Peter to pay Paul? And the funny answer I like to give is we're actually paying both Peter and Paul. So I wouldn't understand why in an arid environment we would be complaining about more rain. It's not the problem of us having more rain, it's doing more to actually capture. And that came up in the panel today. I believe it was Dr. Dima. 2 points came up in her response is it's a long-term investment to do infrastructure work to capture rainfall, which I disagree with. We're at a stage now where we have marketables, off-the-shelf solutions, easily deployable, scalable, where you can harvest rainfall water in an effective, cost-effective way. The other issue she mentioned was weather forecasting. That's not a challenge at all with the satellite imagery we have. I was just attending the panel on satellite imagery. That shouldn't be a challenge, especially in an area like Qatar. We can predict mesoscale systems that are coming in, and we can do a lot to capture what nature gives us, essentially. One important thing I do want to close on is, again, weather modification taps into what nature already gives us. So there's no claim of us sort of creating rain, creating clouds. The technology's not there yet. There's some high-risk research on that being done as we speak, but we're just building on what nature is giving us, and we're tapping into that, essentially.
Okay, well, let me take it to you, Dr. Sudhir. So you're coming from a research background into a startup and SME, and you transitioned from the US originally and now operating into the MENA region. Do you think that there's a major difference between like the regional regulatory affairs related to these non-conventional water resources? And do you think that they go far enough to promote innovation in the market?
So I think the most interesting thing I found from this has been a fascinating discussion, covers everything. But I think from all of it, you realize the one issue which actually everyone suffers from, we underprice water quite heavily. And that's, I think, been a big concern. And that's why when you mention life cycle analyses of the whole cycle of production, when you look at the net cost that water should cost, it doesn't. It's quite cheap. And we suffer from the same issue in the US as well. Water is underpriced very heavily. So I think that's one regulatory issue that I can think of primarily. But here specifically, I've definitely seen institutions like the QRDI and in other regions as well in Saudi, really looking for non-conventional type technologies, really investing in the cloud seeding, for instance. That's quite extensive, both in the UAE and in Saudi, and here in Qatar, looking for other. I've actually seen at least 7 or 8 different institutions or companies bring water production units here to test in the region. And I think that's one of the big issues is the pricing of water. I think if that's fixed, or there's some change in that regulatory framework, that could make a big change. That would reduce waste. That would also, help the oil producers to behave slightly differently with water management, because right now the cost is so low, doesn't make economic sense to address the issues with produced water, for instance, to the same level if the cost of water was higher. So things of that nature would be primary.
Yeah, you're right. I have to agree with that. I think we definitely do see that there is an issue there that could be changed. And I think as well we see that the water sector is very, very conservative in terms of adoption of innovation. When you're installing a plant that you expect to last for 30 or 40 years, it's
Right.
you know, it's very easy to go with the tried and trusted model rather than promote innovative practices. Dr. Esra, let me come to you next, please. We've looked at a little bit at the regulatory side of things. We've spoken a little bit about, you know, the local issues and barriers. Dr. Stephane touched on biosludge earlier, which we haven't had a chance to get into yet. But just on that point, can I ask you about the social and environmental impacts of utilizing non-conventional water resources?
Yeah.
So from your research, how do these kind of inform innovation in the area and utilization?
Well, let me start with the regulation. It looks good that our regulations are very strict. They're more strict than the World Health Organization for water reuse, but this has a high price.
Does it need to be that strict, though?
It doesn't have, yeah, this has a really high, very high price tag to it. Because, for example, the wastewater RO that is generated, which is 10 times more pure than bottled water we drink, it's not allowed to be used unless to re-inject the aquifers or to be supplied to the municipal network. Although we didn't have any problems since its commencement, which was in 2005. The water, by law, is redirected to the farms for produce, and because it doesn't have any minerals, so it's costing more when it comes. They're adding more. The farmers are adding additional fertilizers and minerals for the crops to grow, which is not good. And also the regulations does not allow to use the advanced treated tertiary wastewater for crops, although the vegetables and the fruit that we import 90% of our food mostly is irrigated using secondary water and tertiary. We have advanced tertiary and it's not allowed to irrigate the crops. It's used only for fodder and landscaping, which is a problem. So these regulations need to be adjusted, but again, the parliament do interfere in that. Also, when it comes to the tariff, Kuwait tried to change the water tariff so many times, and then they invested also heavily in awareness, which like the last awareness campaign costed $15 million, and it will give incentives to people who would save on their bill. And out of 4 million people, the population of Kuwait, how many participated? 160.
160?
160 out of 4 million.
160 people?
Yes, so awareness, although they invested heavily in awareness, it did not make any impact. And this is also backed by research, like awareness, if it's not backed with regulations and education, it does not make much of an impact. And we've been trying this in Kuwait, and we had this stepwise function. But when it comes to residential water tariff, people go into the streets rallying for that. So this one, it comes to regulations. When it comes to transboundary water sharing, aquifers, of course, we don't have any policies in the GCC, although the aquifers are really vulnerable. In the last meeting I've attended, when they wanted to write the report, they really had a problem on whether to name it transboundary water or shared water. And they did not reach an agreement. So they just called it groundwater with no adjectives. So it is a serious matter. without, reaching an agreement, we cannot have policies to regulate or in Kuwait and in the GCC, unfortunately, the focus is on expansion and growth. So the SDGs that has to cover more areas in, water provision or treatment, but there's no focus or policies on sustainability and to preserve the water for future generations. So these kind of policies that really we need to focus on, it has to go through education at an early age, because our experience shows that we were not able to convince the public, nor to change the tariff, nor to have people to participate, even if we're giving them incentives. Yeah,
it's amazing. I'm glad to say at least that Kuwait could probably learn some lessons from Qatar in that respect. So Qatar has been quite progressive in terms of its water conservation strategies, its water strategy, its environmental policies related to that. But I'll also say that I'm from Ireland. We tried to introduce water charges and that completely failed. So even though we pay taxes, Irish people refused point blank to pay water charges. There were mass protests and, just it didn't happen. So, I mean, at least there's some sort of pricing here. Mr. Mokrane, let me come to you next. So just in terms of social aspects, as a large company, how do you see the idea of like environmental and social responsibilities influencing SLB and its approach to the water sector? And would you see that there's a difference between the MENA region and other global operating domains for SLB?
Yeah. As you mentioned, SLB is a global company, and it's more important now than before when it comes to social responsibility. Especially, just 2 weeks back we celebrated our rebranding. 1 year of rebranding, and as you mentioned, it's for balanced planets. We have to commit, right? So this is really important. SLB is adopting sustainability goals in our strategy. When we have adopted this a year back, there was a chief sustainability and strategy officer, which was appointed with a big team to look after this. So there's an investment done by the company on this side, and basically, this involved commitment to water conservation, water consumption, minimize the environmental impact. So, and as well, we committed to what we call the net zero in 2050. So it's scope 1, scope 2, and scope 3, which is really challenging, right? If I'm not mistaken, in 2030, we're committing to 50% reduction. So this is looked at a higher level. And private companies, when you commit, you have to deliver, right? You deliver on your numbers, on your revenues, your benefits, and you have to deliver as well on this commitment of SDG, and they can impact you. So every year in the company, we have sustainability goals. They are ranked #1, and most of the employees, they receive those KPIs, and some of them, they receive KPIs. I do have KPIs on sustainability, so I need to ensure that we deliver this in Qatar, and each unit has to deliver this and impact us as people. So I think I found it's real engagement by the higher management to trickle down this, and we own this responsibility, right? It impacts us, and we have to deliver on this. That's a key. When we come into, and as well, it's really important, companies, they need funds, they need investments, they have to go to the banks, and all of the banks now are looking at your SDG. It's not like before a blank check. They look at you, how you are ranked, how you are working with sustainability. Now, going into tangible actions we are doing in the company, some of them are small, but small ones here and there for a large company which has offices in 80 countries, and we have different sites, we have different camps, we have different offices in all those countries. So the impact will be big, right? So for instance, we have a dashboard internally looking at all our consumption when it comes to energy, water, and you can go, and there are dashboards, Power BI, to check that, and we check that into our, compare it to our KPIs. We are as well, we started metering all our facilities in the world, 50% of it, they are metered. So, sometimes you have the willingness to take action, but if you don't have the data, you need to understand where you lack, where you have challenges, to fix them. So 50% of the facilities are equipped now with meters, so we know how much we're consuming. And on the short term, 100% of the facilities would be equipped with the meters. And as I said, we're into digital as enablers, so we will assess that through AI. And we came up they came up from the headquarters to discuss about the opportunities where we have to make change, right? We do have as well internally what we call sustainability investment program. Each person in the company or each facility in the company can come up with sustainability solutions, propose to the board, they review them, and they give a fund and invest. And 20% of it is for water. So, water. I'll give you an example. Our Middle East Learning Center in Abu Dhabi, the biggest one in the region, they are using they are treating the wastewater and they're using 100% for irrigation. The same thing in Oman. So those are examples we are implementing as a company level. For a large company, I think, if you sum them all, they're good examples. Yeah.
Okay, and that 20% now, is that open for collaboration? You need partners for this, because obviously academic institutions are always open to this kind of projects?
Definitely. Definitely, okay. That's something, and they are saying that it will increase by 20% every year. So
okay, good to know. Good to know. We have to get in on this. Dr. Stephane, let me come to you next. So you're from France. You've mentioned that constructed wetlands for wastewater treatment are commonplace in France, and obviously we've imported that type of technology here to the GCC region. But France, obviously, and the rest of Europe is a region that is increasingly suffering from higher temperatures and extreme weather events. Can you tell us maybe just one lesson that Oman or the GCC could teach to Europe in terms of water management?
Yeah, you're right. We have been seeing not only in France but in Europe overall a drought period, specifically during the last summer. And I can see two points that can be actually used from reference in Oman. The first one is actually linked to the standard in terms of wastewater treatment. Basically, in France, the treatment of the wastewater is done as per the specific standard linked to the European regulation, and most of the treated water is discharged in the water body. Based on the flow rate of this water body, then it specifies the quality level you do need to meet. But it has nothing to do with the standards applied in the Middle East that are very stringent in terms of nutrient removal. That's questionable. It can be also discussed in a different session if we do need to meet this level of nutrients in nitrogen and phosphorus if the treated water is to be reused for agriculture. But in France, there is no such decision being made yet on if we are to meet such level of such low level in nutrients for the reuse of the treated water. So far, there is only 0.5% of the wastewater that is being reused in France, and there is a target of up to 10% by 2030. So, in Oman, we have been working on R&D to develop a wetland that meets this stringent standard. We worked on it for the past 10 years. We developed a technology that is meeting the treated wastewater standard from the pilot scale, and now we have 40 full scales in the country of Oman. And this can be used as a reference on existing sewage treatment plants located remotely in the country that will need to then be upgraded. I see it in such a way. In regards to the other important aspect that can be used from the country of Oman or even other countries in the Middle East is definitely the reuse technology aspect. I mean, the treated water has been reused or re-injected. As you did mention as well, there's been some re-injection of the TSE water. This is not existing in France. And I guess that will be the next step. Probably re-injecting the TSE water as a first step in order to store the water and find the appropriate solution in the coming years.
I think you're right, you know, and I suppose maybe one of the drivers for this lack of reuse of treated water has been, you know, the abundance of surface water resources, which we simply don't have here. But I would say as well, you know, there's another side to that coin where we have very stringent regulations in terms of nutrient removal. Because we haven't been discharging to surface water resources, there's been less of a focus on things like emerging contaminants, which are starting to be regulated for in Europe, but not a feature yet of what we're doing here. So I think there definitely has to be a dialogue and a conversation to help both geographical areas kind of transition towards these more extreme weather temperatures and higher value reuse of water all around. Let me go now to Dr. Sudhir. So given that Mr. Mokrane has told us that SLB has got some money for research, can you tell us a little bit about how can industry work effectively and collaboratively with academics to develop and implement innovative water solutions in this region? Because it's quite a new kind of concept for this region, particularly for Qatar.
Sure. The main issue that happens with academic research is it gets stuck in the lab. You're unable to get it out of the lab, and there definitely needs to be a lot of industry participation, which you're saying, which is true. It's new in this region. In the US, for instance, we have a variety of foundations, the National Science Foundation, the SBIR program, and all the different agencies, you know, when they're looking for solutions, they have funds for grants, they have collaboration programs called SCTR, where academic labs can work with industry on specific programs or projects. So there's definitely also a great possibility here, because there are scientific institutions here trying to solve these problems, especially when it comes to water technologies here, where the water use, especially in the oil and gas industry, is so high, and the presence of, you know, large companies like SLB that do actually have the resources to do that. A big chunk of it also is, you know, feasibility studies that you need to do, which you're unable to do as an academic lab, because you just don't know what the cost structures and economic incentives for doing certain things are for industry, and that's where they can really play a good role in helping bring new research out of the lab and implementing.
Dr. Wehbe, I'm going to take a similar approach with you and ask you, I mean, the research work that you've been doing is really, really very emerging. So what are the kind of key financial and investment challenges that this kind of research faces in terms of scaling up, and really these non-conventional water resource projects? How could these be kind of overcome? Has it been very challenging for your research area?
And what I'm about to say applies to all these disciplines that are on the table today. I'd like to expand on what Sudhir said about the essentially going from lab scale to the operational environment. That's obviously, you know, it's a challenge for all unconventional sort of technology development for the field of water resources. Building on what he said, I'd like to go a little bit further on capacity building, public awareness as well. So that's really the value of having more investment in managed grant assistance. And I stress the word managed, where it's closely monitored by the funding organization. For example, in the US, you have the National Science Foundation that assigns basically a PI from the organization who works with the externally funded organization to bring that research out of the lab into an operational environment. I feel that's what's missing here in the GCC region in general. We have plenty of awards, grants, but nothing really on managed grant assistance, where you can really go through the technology readiness spectrum and really get to a commercial value. And the point I wanted to stress on is capacity building. So a key metric in managed grant assistance models, and I'll speak from my experience in the UAE Rainfall Enhancement Program, is we really assign an important weight when we evaluate proposals to have local capacity building from universities. So really ensure that students are getting supported, directly exposed to the research. And that really helps them, helps losing essentially a next generation of critical thinkers who are directly involved in research and losing them to the consulting world. I see a lot of shift in the current employment market, where unfortunately bright researchers, graduate students, PhD students, with great research work, peer-reviewed publications would make a tremendous added value for the research community. They're being hired by these global consultancy firms. Mm-hmm. So that's really a key area which you're getting benefit from when you do these managed grant assistance, aside from the technology demonstrations and going in a proper way across the spectrum, which is also a concern when you don't have that intervention or oversight from the awarding entity, especially when you talk about unconventional solutions. There's plenty of industry players who are entering into the market with sort of not the right scientific merit to sort of back up their solutions and claims that come with it.
Yeah, I agree, and I think we're definitely an evolving RDI ecosystem in this region. But I am happy to tell you that Hamad bin Khalifa University, which is part of Qatar Foundation, last year established a new RDI office, and we now have innovation proposals that bring the researchers the whole way through all the way to getting financing and pitching, business pitching, and how to set up we have a new framework for startups here in the country. So definitely, we're moving in the right direction, but we are definitely still have a lot more work to do. I'd like to thank you all very much again for joining us. It's been an absolute pleasure talking to you, and I'm really looking forward to dinner tonight, actually. I'm going to grab you again. So thank you very much, and thank you very much for those of you for coming as well.